recording this? Oh my gosh. Okay, now I'm recording it. That's unfortunate. I'll rewind, I guess, a bit. You want to then do some measurement, right? So I'm just going to quickly scroll back here just so I can capture just bear with me quickly, because I wasn't recording. So just to say, to recap, we started with looking at the impact of fires. This is about fires and environmental management tools. I'm rewinding here. We're looking at fires, whether it's a problem. It sure is. We look at what's happening in BC right now. This is the news today. And we start to look at what the NRCan is saying about fires, which is the fact that the amount of burnt area can double by the end of the century as a result of climate change. We need to look at the literature. So here's one piece of literature about the interactions between fire, climate, and biomes, impact of anthropogenic climate change and wildfires in the US, and one on fire frequency and extreme fire weather in Canada with climate change. Some of the models, positive feedbacks, Lawrence and Williamson. Here's their model for the positive feedback system for evapotranspiration and deforestation. And then a model that I came up with for the relationship between road building at its large scale and then small scale processes like burning land and deforestation. Some observation of a clear atmosphere to a cloudy atmosphere. That's 6 a.m., 10 a.m., about 4:30, and then 7:30 p.m. And that's in Amazonia and the Rio Madeiras. So we're starting to see there that negative feedback system, which is evapotranspiration. You observe the system. That is the top right there, precipitation and evapotranspiration. And we can start to flesh out the relationships by model. So we start to think about this stuff. Thinking about the problem requires looking at the literature, looking at how things relate, and systematically breaking it down. Good, we just got all caught up. Then we do some measurement, right? We need to try and, it's one thing to model, and this is where the camps tend to battle against one another, the modelers and measurers. I tend to be more on the measurement side than on the modeling side, but I appreciate what we need to do with modeling. And this is where this image here is fire frequency from 2001 to 2006 in a place called Mato Grosso, which is a state in the Amazon, and you can start to see those red dots there are something called hot pixels, and they are detected from space using, in this case, it's MODIS, and it detects the thermal band. So this is like a satellite image detecting where things are really hot on the surface of the Earth, right? So you can start to see there that there are certain parts where you get much more density of red pixels and even those higher colors like purple and yellow and so forth, and that's where fire frequency is really high. So you start to say, well, where are we having these problems? Well, it's actually in the center of that image there. You can see it a bit yellow, yellow and red. That's where all the development's taking place, right? So measure it, start to look at it, because we cannot manage what we don't measure. And remote sensing is a good way to get at some of this stuff, especially when we're dealing with large spatial areas and we're trying to detect stuff that we can't see with our human eye. We need to detect the thermal band, right? So it's not something we can detect on our own. And then we start to quantify this. So if you start to look at this graph here, this is 2001 is the orange. So on the bottom there, we see the month. That's January, February, March, April, May, June, July, August, September, October, November, December. And then that's in the x-axis. And on the y-axis, we have fire frequency, which is measured from those hot pixels. In that bulk area, I'm counting, well, I'm using statistics to aggregate the number of fires that had taken place in those months, in those years. And you need to look at these things over space and time, right? Why? Because climatic conditions, the environment changes over space and time, right? Obviously. And in this case, there's distinct seasonal patterns, as we have in British Columbia. In this case, you start to get the dry season is from basically June, July, August, September, October, November, that stretch there where you can see the peaks. That's known, it happens every year. You get far less rain during that time. However, in 2005, we had a drought. We had a drought in the Amazon, which was credited to a change in sea surface temperature in the Atlantic. And you can see there that the amount of fires doubled in that year during the dry season, right? So we start to see these patterns. We start to measure these patterns and say, okay, well, something's going on here, right? We're starting to get data that relates to the model that we've created. This is great. When I got these results, I said, holy cow, this is going to be cool. How far back do the records go? Good question. Any questions, please ask them. Well, good question. So in this case, it's not a record, right? I'm observing the Earth using a satellite. So the record for this goes back to how long that satellite has been capturing data. So in my case here, I was using a satellite called MODIS, so a record of fires. Well, this case I was using something called MODIS, and it was launched in 1999. So for this, I could do this and look at the fire frequency and so forth. Well, in Canada, I could do this in Canada too if I wanted to, from 1999 up until present. And I could look at fire frequency. I could look at where the fires are, how many of them, it's a spatial relationship, all that kind of stuff. We're limited in this case, and in fact, we talked about this last week with just the evolution of technology, right? So we were only able to get good at this stuff, at least for MODIS in 1999. And you can go back further, like Landsat, you could do this type of analysis too, and you could go back to 1974, I think, 72, 74, something like that. So you can go back to around that far for this kind of observation. And then others, if we wanted to go and look further back, then I would suggest that we'd probably want to look at maybe aerial photographs, say in British Columbia, or any kind of documentation that we could gather, maps where people had recorded the presence of fires. But that's a limitation you always have to deal with is, what is the data? And also the other thing with this kind of work is making sure that, whatever you're using is comparable, right? Like comparing Landsat and MODIS is difficult because they're different spatial resolution and different spectral resolution. So you need to make sure you can transform that data to make sure like this is equal to this. Otherwise, it's not a good comparison. Does that make sense? Think first. Do the background research. Get grounded in the literature, whatever it is. In this case, fires. Start to look at who's been working on it. Modern as well as older literature. So I've showed you some stuff from '99 and mid 2000s, like Cochrane and Lawrence and Williamson. That's 2003 and 1999, I think, those papers. So, but it's still good literature. It's good research. And then we look at the modern stuff to see what's going on. Just anonymous about fires. Not yet. Not yet. And we'll get to that. Um, uh, well, at least I can speak for Amazonia. So I can't speak for BC temperate forests, but I know in tropical forests, what it does do is it increases the frequency of forest fires because of edge effects. The fragmentation exposes the edges, it makes them more dry, and makes the potential for fire greater. That's what happens there. Maybe different in temperate systems. I don't know. I'd have to look into it, but the tendency is towards that. Yeah, intuitively, I think we can come to that conclusion, but I don't know. I mean, I don't always. I mean, I really need to see studies to say something for sure. I know for Amazonia, that's the trend, and the reason for that, in terms of at least Amazon, is just because the coupling, right? When you start to defragment a forest in the in Amazonia, it really affects the evapotranspiration. It really affects that coupling, so it becomes less like a tropical forest. It becomes less humid, and then you get more fires. Yeah, this is a question that I would start to look at. I mean, let's just say we're getting hired to look at this stuff. In fact, I'm going to try and talk to the government folks that I know about this because I think we need some technology. Defragmentation. Defragmentation. Like, what do you mean defrag? Like reversing fragmentation? Okay, no, I mean fragmentation. Fragmenting the forest through typically fragmentation, at least stuff I've worked on, is a result of pastoralism. And pastoralism is small-scale disturbances, usually farmers, families, that go and they go out into the rainforest and then they chop down like a hectare of land, and then they grow cows. Depends. Do they practice replant silviculture? Yeah, I mean, it's called swidden agriculture in the literature, where you more and more, it's more happening more often, where you deforest and you grow whatever you're growing, and then you rotate. So otherwise, you deplete the nutrients of the soil. There's not as many nutrients in the soil in those systems as there are in, say, in temperate systems, like phosphorus and nitrogen. So you kind of have to rotate your agricultural practice. And then you also have agriculture there, so people raising cows. But there's a lot of work going on, integrated agroforestry and stuff like this now, and it's good to see that happening. But the other thing is, like cattle, growing cattle is different because you need to think about the economics of it, right? A cow is like just a big chunk of cash, like, and it's liquid. It's a very liquid cash, right? So if you have like 5 cows and you need money right away, boom, there you go. Like you take one of those cows, to the slaughterhouse and go to the market, and then you've got cash. Whereas agriculture is not as liquid. Right? You have to wait for things to grow. There's a little more risk too, because you could have some infestation or what have you. So this is the popularity of cattle, growing cattle is because of that. It tends to be a higher cash crop and easier to manage. Risk is increased with climate change as well. So I mean, this is a friend of mine works on this stuff, and I learned a lot. I shared an office with him at McGill, and it was very interesting to learn about the economics of pastoralism in some of these places. You can think about it as like a walking chunk of cash, cows, which would make a lot of Buddhists freak out, but that's how it works there. So a management framework. How do we deal with this thing? Okay, well, monitoring an EIA. What contributes to this problem? So we have there's different. This is actually going back to the disaster frameworks. We have droughts, landslides, floods, sea level rise, tsunamis, earthquakes, high energy storms, and put fires in there as well. And those are all like disasters or major disturbances, right? So we need to identify the preconditions and determine how ecosystems can play a role in minimizing them, but we need a framework. So this is a framework that I think we had talked about before in the context of agriculture, but the same thing applies to forest fire management, right? Same idea. So we have risk mapping or risk prediction as the kind of the tool, or the EM tool that will be, would be a good thing to be using in this situation. And then along that we have risk identification. So first and foremost, identify and quantify the risks and link to vulnerability. So if we were to look at this in British Columbia, we'd start to say, well, where do we think that there would be a high risk of a fire? So we'd need to look at, say, climate model output. It's going to have to, like, from into 2020, 2025, 2050, 2100, and that's going to tell us, well, at least give us some estimation as to where we can expect there to be some disturbances in the future, or droughts where there be fires, and we can put together whatever the factors that contribute to that. Prevention and mitigation. So reduce the risk through structure and non-structured measures. So like we've talked about, so for instance, reducing prescribed burns could be part of that. We could be looking at other means of reducing, mitigating those risks. I would say, I don't know. It'd be a few different things that we'd want to think about in that case. Perhaps even some different forestry practices, I'd say, would be something we want to think about as well. Next, we have financial protection. So transfer of the risk to reduce direct losses. So ensuring that people have proper risk in areas that are prone to fires, right? Same with floods. Preparedness response is what we're doing right now, is conscious and adequate response capacity. Do we know what to do when things go sideways? I think we're good at that. Like Canada's very good at that. So we've got the military on this. We've got a lot of resources being devoted towards that. We've got a lot of experience fighting fires in this country. So, but we may need to start to look at more and different different ways of addressing that and more capacity. It's hard to say. And then lastly, recovery. So recovery mechanisms, continuity of operation. So we've seen this with Fort McMurray with the fires there and previous situations. Can we recover quickly and then keep things going? So continuity of operation is really important, as well as rehabilitation, reconstruction. And we need to think about that. And this is something that tends not to be thought about in some cases. And it's like, well, we just have a major disaster. It could be a fire, it could be a flood, and then everything goes sideways because we didn't have any, we didn't have recovery plans that would allow us to keep going, at least in maybe have a diminished capacity. So all of these things are important. And these huge fires are burning so hot that soil is cooked in some areas. How to build up the soils. Good example, So I don't know. Do you have any examples of nurse systems, like how to build up the soils to regenerate forests? I don't. I mean, I'm working with one guy. I'll have to talk to him. I don't think it applies. We use it more for agriculture, less for, say, forests, which is where we have a technology which can help keep. It's like a polymer bead that can help keep precipitation in soil. It's good for growing things in arid conditions. So we can grow like mango trees in desert, basically, with this stuff. And possible that could, or something like that could play a role. Because I mean, basically what we're doing is we're keeping the soil moist with that technology, and allows us to then even grow mango trees with the saline brackish water. Like, it's incredible. So there's those kind of things are the things we need to think about to help regenerate it, but also help to potentially help minimize the risk. If we can keep the soil moist, perhaps that can reduce the probability of a fire occurring, right? What about drones, right? So let's just say we have a solution where we have remotely sensed imagery, and then where we detect there's going to be a hot spot, and we know there's a predicted hot spot, we deploy drones, and they spray, I don't know, water or some sort of like benign fire retardant water, I don't know what it could be, to minimize the risk of there being a fire. I mean, that's the kind of, I'm starting to think in those terms, where we we precisely know where there might be some risks, and bang, we can deploy, things to help reduce the risk of there being a fire before it happens. So we don't have that massive issue that we have to deal with. Part of it would be prevention too, through making sure, and restoration of the land afterwards. Has anyone tried that? I'm on it, right? Honestly, I literally, I've talked, I'm looking at it now. Seriously looking at it. I'll be talking to the government tomorrow, BC, the province. So, what EM tools do we need? Right? So this is the interactive part of the discussion. So we know that we cannot manage what we do not measure, right? We know this. Hopefully, I think that's one thing. If you've learned anything in this course, it's that. If you don't have a handle on the problem, whether it be greenhouse gas emissions of a company, or whether it be emissions of effluent from an organization, or whatever, even socioeconomic factors, if you don't know how much you're donating to charity on a quarterly basis or an annual basis, you are not going to be able to report to the GRI, for instance. So we cannot manage what we do not measure. So we have a big problem on our hand. We have a growing fuel stock of massive fires in our country. So we need to measure. We need to find ways to do that. So we need to measure. I've written it there. For one, we need predictive models. So we need to anticipate where there could be a problem. I would say this is just my thoughts. And I think there's different ways we can do that. Process models, and I think observation, I think, is part of that as well. I think also, as John had mentioned, we really need to talk to First Nations. In fact, a friend of mine who's worked a lot with First Nations, this is before the mountain pine beetle, had talked to them, and they said, you need to burn it all. You need to do a prescribed burn because our winters are getting too warm. And the First Nations recommended a very massive burn before this mountain pine beetle infestation. And the reason for that was they felt that they were going to get a mountain pine beetle infestation. And it didn't happen, and look what happened. We had a massive, massive, massive problem. So I think we need to start to integrate traditional knowledge into this predictive model as well, right? And so that would be, I think, something we need to think about. We need to observational methods. So there's some challenges there. So like Brad's mentioned, CEA, cumulative effects assessment. Yeah, I'd say CEA is part of that because I think like why cumulative effects? What's accumulating here? Like the nature of a cumulative effects assessment is that there's more than one thing contributing to a problem, right? Environmental change, sure, and then also I would say um, just development, right? So if we look at some of these regions that are experiencing a lot of fire, there's a lot of different um, activities in those regions, right? Many different projects going on. Urbanization could be part of it, right? So we looked at urbanization would be something we'd fit into the CEA. I'd also think we'd want to look at forestry to see what kind of forestry operations are happening. We would want to look at environmental change in general. I think an SEA as well. So we need to look both CEA and SEA to look at what policies are contributing to this problem. Absolutely, right? Because SEA, strategic environmental assessment, is pertaining to policies, programs, and plans. So an SEA focused on fire, I think, would be a wise decision for the province and the federal government to look at, probably across Canada, I would say, but particularly in the areas where they're most dramatically affected, and focus on that issue to see what could be contributing to it. Could be an urbanization, um, could be forest practices. There's a lot of different things. I mean, I haven't looked deeply in it, so I can't say for sure, but I would say an SEA framework. I'd say CEA is part of that as well. In fact, I'd probably combine them. Like we've looked in, there's one of the papers we talked about connecting CEA and SEA, I think. I forget what the title was. But yeah, those are a couple of the tools that we would need to look at for sure. I think we'd also want to have like an EMS though, right? Because CEA and SEA tend to be kind of programmatic and strategic in nature, but an EMS is more dynamic, correct? Like think of it as an organization. Like so, let's just say the province of British Columbia is the organization that we're managing. So in any kind of environmental management system, you need plan, do, check, right? So you want to plan to reduce fires and the impacts of fires. You want to have then ongoing monitoring. Yes, exactly. That's it. So we'd want that implemented as well. I think an SEA and CA will help to allow us to see the landscape of risk and impacts and so forth and what's contributing to the problem. But we need a good old-fashioned environmental management system, I think, right? So we can keep on going, keep on monitoring these things on a regular basis. Because it will change. We know this, right? So this is old school adaptive management. We'll go back to Buzz Hauling type stuff, right? So there's clearly the need for environmental management tools, and not just one, a variety of different ones in addressing this problem. I think also at the micro scale, we need to think about how projects are being approved from an environmental impact assessment perspective to see that there's, is there a component of fire risk associated with that for sure. So it's another dimension to it at the very kind of project level. So a few different ways. So one of the challenges, or some of the challenges that we need to think about though, because one of the observation methods are temporal frequency. So if we take this comment, Enrico's comment about the plan, do, check. Again, someone's hijacking my. It's okay. It's a ghost. It's a climate change ghost. It's doing it. So we want to look at the plan, do, check cycle. We need data, act. We need to then have data of sufficient temporal frequency, right? So that's time frequency. Are we checking every year, or do we need to do it more frequently? Now, I would argue we need to do it more frequently because the changes that we're seeing tend to be more happening quicker. The frequency is quicker, and also more in the spring and summer. Absolutely. Like Would we need to be focused on this in the winter when we're getting bucket loads of rain and so forth? Probably not, right? For one, it's snowy, so if you're doing an Earth observation, you don't see anything, like it's cloudy. But so temporal frequency is part of that. You need to like strategically pick where and when we need to look at this stuff. The other thing we need to think about is spatial resolution. So over what spatial resolution do these things occur, right? So if we're looking at an EIA standpoint, that's a project level. That tends to be, I don't know, kilometer level. Whereas if we're looking at, say, a broader impacts, we might need to look at a broader, spatial resolution. We also need to think about spectral resolution, and this is more pertaining to remote sensing. But it pertains to other things as well. It's like, what are you able to see? What do you need to see, right? So in our case here, I've demonstrated how to detect fires from space. And in order to do that, we need to detect things that are in the thermal bands, things in the part of the electromagnetic spectrum that are warm. So we need that. We need to detect that. And I think in parallel to spectral resolution, I think you could say cultural resolution. I think that's a good idea. That's a paper actually, maybe. Cultural resolution in environmental management. Yeah, I think that's a paper. Because that is the perspective that you view the system. Cultural resolution. I think I'm going to expand. I just came up with that. So this is just like I had like a, this is John. I got to give John credit for this. Cultural resolution, right? So we always say in environmental assessment and stuff, and sustainable development, the lens. Like, what lens are you looking through, right? Are you looking at a scientific lens? Are you looking at a sociological lens, economic lens, right? That's the way you look at a problem. So I'd say that we need to also look at a different cultural lens, and I'd say like cultural resolution. It makes sense in this case because you're able to see things differently with a different cultural perspective. That's going to allow you to see things with a different resolution, like visual resolution. I'm trying to make a bridge between like observation in the scientific sense and then kind of cultural anthropology. So cultural resolution, spectral cultural genus, something like that. I don't know. I have to think about this more, but I like the idea of this. But this can allow us to see things. Well, for one, the cultural resolution or perspective will allow us to see over a different time frequency, and we'd also be able to see things differently, right? I don't know. I think that's a neat idea. So cultural resolution I propose would be taking traditional knowledge and interviewing First Nations folks and asking them what their experience would be with forest fires and so forth. And we could couch that in that term. And that could be incorporated in the CEA, in the SCA, and in the environmental management system, perhaps, as well as in EIAs. Oh yeah, I didn't even. I heard that. I heard that comment, but I didn't. Someone told me about that. I didn't really. I didn't really get. I got to look at that and see what he said on the news. Something about Canadian forestry or something. So yeah, those are some tools. I mean, that's good. I mean, you put together some things that I think make sense for addressing this problem that we've learned about CEA, SE, at least in a very kind of like generic sense. So what do we need? We need response plans. We need insurance too. We need recovery plans. We need to look at full costs. That's the other thing we haven't talked about here. We haven't looked at full costs, right? So in any situation, most organizations are going to say, okay, what are we going to do here? What's the return on investment? What's the cost, right? So what are the cost of the fires, right? I mean, there's the immediate cost with the damages and losses, and then the cost of deploying troops and people to kind of take care of it. That's stuff we can add up, right? We can get that cost. What are the other costs? So, like, what do you think the costs have been on tourism in British Columbia? Hard to say. And that's just in the short term. Maybe there's longer term costs. So we need to think about those things. I think we need to look at that. We also need to think about that. I think we need to think about that in general, especially if you're in political leadership, you need to think about these things. Think before you talk. So I have to argue that our federal government sometimes has difficulty with that. But Loss of plantations, yes. There's the loss of replanted trees and actual product. So product loss, industrial loss, economic loss. So this is how we need to, every community needs an emergency fire management plan for their landfills. This region after the fire camp. Yeah. So, I mean, that's kind of, yes. So there was a marathon, I think it was the marathon that got, they bust everybody out. I don't know if it was a triathlon or marathon. Penticton, maybe? Heard about that. Yeah. So nope, it's not safe. I was having a meeting at UBC yesterday, and the guy Les I was meeting with, he had said he had his meeting with one of the head people in public health for UBC, and he was saying that one of the days last week, if you were hanging out downtown Vancouver for more than a few hours, it was the equivalent of smoking 3 cigarettes. Can you believe it? So in terms of the ingestion of, yeah, it's gross, definitely. And particulate matter is what you'd be ingesting, which is what you'd ingest from a cigarette. When I arrived back from St. Lucia, that was last Monday, yeah, I got off the plane. I normally go for a run or whatever, do something to ground. And I looked outside and I'm not running. I looked, they said it was safe, like if you had respiratory problems, it was going to be it would be a health risk, but a normal people. But I just looked at it was just too smoky. It seemed like a good idea. And I've never had that experience in Vancouver. And it looks like we live in Hong Kong, like in a polluted Asian city. What like the pictures of Beijing and a bad day. Can't see the mountains. Yeah, so we need to take care of this problem. That is for sure. We need results. No more blah blah blah. We need to deal with this. Yeah, business continuity planning, full cost accounting. I think we need to think about. We need to think about the monitoring systems. There's a lot of stuff that needs to be thrown at this problem, but we have resources to deal with it, so we need to get on with it. We have people like you guys who are now capable of, in your own areas of work and so forth, to speak up about it, right? Even at the company level. Good. So, I mean, that is. Review of what's a WNB? Oh, okay. Yes. Yeah. Yeah. So we'll see. I'll talk to the. Do we need to get through relocations? Yes, we do. That should be part of it. Yep. That should be an emergency response plan. Relocation is part of that planning. And compensation, insurance, natural cost, loss of habitat, soil region, sedimentation, fish stocks, all that stuff. Yeah, I agree. Natural costs. But we should know that. That's the thing. Like we should have an understanding of these things. I think we need to start having a better handle on our natural capital assets. Once we know that, then we know what these things will happen. It's knowing how much money you have in the bank. I don't mean to this is not me saying we need to monetize everything, but it's me saying that we need to understand this. And we do need to think to some degree in this way, because it will help us to enact policies that even the most conservative of thinkers will be able to relate to. This is how I address these people. When I have to present to bankers in Mexico, I talk in these terms. And they listen. As we've discussed in the discussion, though, as well, like we always need to keep in mind that there's culture and values that on top of which values that underpin economic valuation, right? All right, so if there's not any more questions, I'm going to cue the music. Yes.